Hello everyone. Now let's continue our discussion on the multiple access in the S02.11. Okay, so um, now in the S02.11, as we have seen before, the protocol multiple access protocol is called CSMA. So it's instead of using this collision detection, it is more into avoiding collisions because if there are two or more nodes transmitting at the same time, then there will be collision. So our goal is to avoid the collisions. Okay. So as you know, as we have learned in the previous chapter, CSMA is sent before transmitting, and then there will be another mechanism to avoid collisions. And then in 0 to 11, there is we cannot do the collision detections. Why? Because it is difficult to sense collisions. Unlike the like if you are using the cable networks, then the collision can be if there's a collision, then it can be propagated to the cables, right? But then in the wireless, the transmitted signal will be it's very weak, and it's propagated and it's become weaker. Okay. Now, uh, and also all the nodes will not be able to sense the collisions in any case due to the hidden signal problems or due to the fading. Okay, so let's say if there's collisions here, and then maybe not see cannot hear if there is any collision. So our goal is to avoid the collisions. Okay, so that's why it's called the CSMA CA collision avoidance. So now let's see how this collision avoidance is done in CSMA. Okay, so this is the first attempt or the first version, not the first version, because actually they have additional mechanism which is better to manage the collision avoidance. Okay, so first, similar to the CSMA sensor channel, if it is idle, so we add this kind of to this time interval, DIFS um, interframe interframe. I don't remember the what it stands for, but basically this DIFS is after this certain time, if this channel is idle, then we transmit to entire frame. We try to transmit we start to transmit the entire frame. Okay, so no CD, no collision detection. So if there is any collision, then just back off. Okay. If sense channel busy, then start random back off time. So again, this is the same with the CSMA, normal CSMA. The timer counts down while channel idle, so counts down, and then when the timer expires, so when because when we take the random back of time, then the timer counts down, and then when it off, then we start to transmit. Okay. But then if still busy, then we still wait again, increase random back of time. Okay, if there's no acknowledgement, or meaning that the data is still transmitted, and we'll talk about the acknowledgement later. Then we receive again, we repeat this step. Okay, again start random back of time, and then counts down until the timer expires. Okay, now at the receivers, the receiver has to send acknowledgement if they receive all the data. And this is very important. Okay, so the acknowledgement is sent after the short interframe, I don't know, I think S is interframe something, okay? And this acknowledgement is very important because this is like, this will be received by all the nodes, okay? Received by all the nodes. And due to the hidden terminal problems. So this is just partly solving the hidden terminal problems. Okay, so to really solve the hidden terminal problems, then the CSMSCA also has another mechanism by using so-called the RTS and CTS. Okay, so for the sender, if the sender wants to transmit data, so it starts by sending a small request to send packet. Okay, so this packet has to be small because it may collide with the another RTS, but since it is small, it is not. I mean, we're not wasting a lot of time, a lot of frames. Okay, so and then when the base stations or the receiver receives this RTS, okay, by one from one sender from one terminal, then it broadcasts, okay, broadcast the clear to send or CTS. Okay, now the CTS is broadcasted and then heard by all the nodes. So for the sender, it is a sign that, okay, so it's like the green light for the sender. So now it can start to send or transmit the data. But for the other for the other wireless nodes, it is like the red lights. Okay, so now you have to stop. You cannot transmit any data until the data is finished. Okay, the data that is sent by this uh, going to be by this transmitter is finished. So now let's see from the from the illustrations. Okay, so now let's say we have the access point, node A and B. So in the first trial, node A and B sends the RTS at the same time, and then this RTS collides, and then, okay, both of them, they take this random back off, and then eventually A has the chance to transmit RTS first before B. So it sends the RTS to access point, and access point receive it, and then access point broadcasts the CTS to node A and B, and actually to all the nodes that is associated with the access points. Okay, so for A, so it says that CTS-A, it's saying that, okay, so now A can start to transmit the data, and for B, it is called that it is said, okay, so CTS-A, it means that the A is going to transmit data, so you have to defer. Okay, you have to defer now. Okay, so now A can start to transmit data. Okay, so and when the data is finished transmitted by A, after that SIFS, a short interframe time, then access point sends the acknowledgement to both A and B. So this means that, okay, so for B, now the data has been finished to be transmission from A is finished. So B can start to again transmit the data to access point. Okay, so that's it. The explanation about the CSM and CA with the RTS and CTS mechanism in 802.11. We'll continue with the frame addressing or the MAC address in the 802.11 in the next video. All right, so see you again in the next video then.